All right, stats, here we are. This is your Wednesday, the 27th notes video. Here we are, chapter 12. Have that packet out, whether you have it printed out or you have it, probably don't have it on the iPad if you're watching it at school, which I know you are, or your Chromebook. Have that bad boy out. We're going to start on page 18. Actually, so I will, it is official unless something terrible happens, I will see you on Monday, November 1st. Just got back from the surgeons there at Barnes Jewish. What an incredible complex that whole area is. Everything's great. Everything's good. I might see some of you guys actually on Friday. I'm going to come in and just drop a whole bunch of stuff off. Kind of get a lay of the land of my room and anything else I might need to bring on Monday because I got to still stay a little comfortable. I got to use the knee scooter for probably 6 more weeks. So, very excited to be there in person with you all. All right, I will see you on Monday. The notes videos will end here. Now, this is Wednesday's video, so if you're watching on Wednesday, you know that you have a homework assignment to do to me by midnight. One of you has already submitted that. Very good. It's the Chapter 10 homework set. There's only, 5 questions. I literally gave you a homework help video, and then the quiz review video for Chapter 10. It could not be more similar. So take your time, show a bunch of work with that. All right, so let's talk about page 18. This is page 18. Where's the one with rain? Oh, I think I just made up an example. So page 18 is good. It just gives you a whole bunch of formulas. If two things are disjoint, either one happens or the other one. You know, like if you win 76% of the time, then you lose 24% of the time. If you there's no tie, something that has no ties. If you make 80% of your free throws, you miss 20% of your free throws. So you're either gonna, the probability that you either make it or miss it is 0.8 times plus 0.2. It's 1. Conditional probability is this. Now, granted, I write it as A given B, but whatever the given is, that's the denominator because that has to happen. This is say, given that this event's going to happen, so it's going to happen, what's the probability that A happens? Well, I'm sorry, that B happens. Well, if A happens, and I want to know what's the probability of B happening, then the numerator's got to be their intersection. So you're probably not going to get that formula. That's a formula that you have to know that is typically not given on formula sheets. Now I'm just going to be consistent. What does that SIU give? What does SLU give on formula sheets? All right, 2 things are independent, and I'm going to give you some independent notes, I believe, on Thursday. Then the probability that A and B happens is probability of A times probability of B. All right, and we'll talk about, actually, independence here right now. That's why I have this written down. Okay, so let's say, sorry, I am actually filming again here in the basement. I've been cleared. If I can crutch up and down stairs to do that. And we're down here because Yogi can't handle anyone outside. And I can't lock the dog up for 3 hours a day in the bathroom when I'm home. That is all good. Okay, so the probability of A and B, the probability that they both happen. So it rains Wednesday, 60. That probability is 0.60. It rains Thursday, probability is 0.50. These two are independent of each other. Okay, these are 2 independent events. So because they're independent, the probability that they both happen, probability of A and B, is equal to the probability of A times the probability of B. It's 0.30. Just general multiplication. You kind of know that. You've already done that with free throw shooting. You've done that with the probability it rains, probability of you passing tests. You've done that before. All right, so let's talk about more. Is this the first? No, I don't think this is not the first video since the homework. Again, submit that homework on time and try to get it in one document. All right, again, if you don't have an iPhone, Cam Scanner, Genius Scan, do that. If you do have an iPhone, that notes thing works really well. Notes, scan documents, emoji video. Technology this is in your wheelhouse. Let's make it look good and professional, okay? Thank you. So general multiplication, if they're all independent, the probability that they all occur, just keep multiplying. This is it. So have this together. So the probability of A union B, union means or, is equal to A plus B minus their intersection. So just know that. You really don't need to know. You'll just know how to multiply. That's not a necessity. But this one right here, this formula, two things are independent, this formula, which is the same thing as this formula. And then this one right here for conditional probability. Those are ones that you're probably going to have to know. All right, so let's go to page 19, Instant Lotto. So again, it's interesting. The SLU uses this book. This book asks a lot of really easy questions. Most of our better questions don't come from this book. So it's interesting. We've got better resources, but there's a lot of really easy questions in here. Now, check your skills. I think those are supposed to be easier examples. But what's it say here? 12-17, an instant lotto game gives you probability of 0.02 of winning on any one play. Plays are independent of each other. You're going to play 3 times. What's the probability that you win on none? Again, let's get in the habit of writing everything we know. Let's let X be, the occurrence that you win the lotto. So the probability of X is 0.02. Probability that X is 0 is 0.98 to the third. Be in the habit of writing all that for your homework. 18 says, what's the probability that you win on at least one of the plays? Well, probability that X is greater than or equal to 1 is 1 minus the probability that X is 0. I need to follow my own advice, and it's that. All right, let's talk about 12-19. An athlete suspected of having used steroids is given 2 tests that operate independently of each other. Test A is probability of 0.9 to being tested. Test B, probability of 0.8 to being tested. Be positive if steroids have been used. I don't know what I was reading there. What's the probability that neither test is positive, but they are actually using steroids? So it is the probability of 2 false negatives. So someone is actually positive for steroids. They're actually have used steroids, but they get a false negative twice. What's the probability of that? So the probability of getting a false negative on the first test is this, times the probability of getting a false negative on the second test, 2% chance. 2% chance, which is an outlier, but it's not unheard of. All right. Now, we are actually going to skip because we're going to write this next part, 1220 to 1223 on another paper. So I'm going to look at 1224. Choose an American adult at random. The probability that you choose a woman is 0.52. Probability that you choose someone that is never married is 0.25, and the probability that you choose a woman who's never married is 0.11. The probability that the person you have chosen is either a woman or never married, both, is therefore what? Now it's not 9.77. About 11 is important there too. So, a lot of times in college classes they want you to find something, so you might have to read through it a few times. So if A is the probability that you have a woman, that you choose a woman, the event of choosing a woman, and B is the event that someone is never married, then the probability of A is 0.52. The probability of B is that, and then the intersection of woman and never married is that 0.11. So the probability that you pick someone that is either a woman or never married or both, probability of A plus probability of B minus their intersection. You have to subtract the intersection or else you're over counting. So 0.66. All right, cool. Let's go to the next part. And the next part is violent death. All right, in a certain area. Or maybe nationwide, I hope. So here's the table. Accidents, suicide, and murder are the leading causes of death for young adults. Here are the counts of violent deaths in a recent year for people 20 to 24 years of age. Choose a violent death in this age group at random. Now notice how I think you should add this in, the totals. Add this in. Because I'm going to ask you... Can I ask another question? I don't think so. I just put the totals in here. All right. That's going to be helpful. Choose a violent death in this age group at random. What's the probability of the victim's male? Again, I want you writing probability statements. Probability male is, this is anybody, so we're using the total of 14,099. And 11,479 of them were men. 0.815. What is the conditional probability that the victim was male, given that the death is accidental? So the given is always written second, and that's the denominator. So the probability that they're male, given that it was an accident. So if the death was accidental, that goes in. That's the denominator. How many accidental deaths did you have? 8275. And I want the intersection of an accidental death in male, which is 6457. All right. 0.780. The conditional probability, and you're like, this is the same thing, but it's not. The probability that the victim was male given the... I'm sorry, I'm reading the wrong one. I was like, I'm literally saying what I just said. 1222. The conditional probability that the death was accidental given that the victim is male. It's all about the given. This time, yeah, I'm using the same words, but I'm flipping them here, all right? So this time, males are the denominator. I need all the males. So from the males, what proportion of them are deaths or accidents? That's another way you can say this. All right, so the intersection is still the same. The numerator is still the same because I'm still looking at the intersection of accidents and males, but my denominator is different. All right, so be very careful because it looked like I was saying they were saying the exact same thing, but you're not. Ooh, man, 1223. So actually, sometimes... I mean, you can get the answer and then go backwards here. So 1223, let A be the event that the victim was a woman and B be the event that the death was suicide. The proportion of suicides among violent deaths of women is what? So first off, among women. So woman has to be the denominator. It wants to know what proportion of deaths do suicides make up in females. So the denominator has to be how many violent deaths among females, and the numerator has to be suicide. So the numerator is, that's not union. A intersection B, B intersection A, but the denominator is A. It's the violent death of a woman. So this is the given. So A needs to be written second. It's probability of B given A. B given A. Given that you're choosing a violent death among women, what's the probability that it's suicide? All right, and that's the answer. Nope, I did add another. So in your notes, add this, add another. Given that A reported, I might need to pause this. Given that A reported violent, pause it, death was a homicide, given that a reported violent death was a homicide, what is the probability? What is the probability the victim was male? What's the given is it's a homicide. So probability you pick a male given it was a homicide. That's how you need to write that. I always want to see a probability statement. All right. In your chapter 12 notes, like, did you do your homework? Just like this. All right. So of the people that died by homicide, it was that many. That's how many were men. There you go. Always round probabilities to 3 decimals. All right. We are going to look here. Next up. What is next up? We're just going to keep going here. 1225. 1225. Of the people who died... Just all about death here. All the people who died in the United States in recent years, 86% were white, 12% were black, 2% were Asian. This ignores a small number of deaths among other races. I'm sure Hispanic population is being put into the white category there. Diabetes caused 2.8% of deaths among whites, 4.4% among blacks, and 3.5% among Asians. The probability that a randomly chosen death is a white who died of diabetes. All right, so I just wrote all that down. 1225, what's this? The probability of a white individual who died from diabetes is probability that you chose a death from a white person times the probability that the death was caused by diabetes. There you go. And then using this information, and I put add this, but that's exactly what it wants. Using this information, what's the probability that a randomly chosen death is due to diabetes? All right, probability of death by diabetes. So 0.86 times 0.28, that's from the white population. This is from the black population, 0.12 times 0.044, and this is from the Asian population, 0.02 times 0.035. Now you're dealing with some small numbers, so most of the time we round to 3 decimals, but man, we've got some, we don't want to round this to 3 decimals. We want to be pretty precise. So it still comes out to be 3%. I don't know why, because I made up a new question before actually reading it fully. So let's just say my question is, diabetes causes what percent of all deaths? So 3%. All right, we're going to keep going. Talk about Lester. All right, so you got the New York Lotto, quick draw lottery. You can pick a number between 1 and 10 numbers from 1 to 80, and they're going to pick 20 of them. So, and you can have, I guess, duplicate numbers. If you choose just one number, your chance of winning is 20 out of 80. I'm assuming you can just pick numbers multiple times, and then, all right, so Lester's going to play, I don't know how New York State's quick draw lottery goes. Lester's going to play one number 8 times as he sits in a bar. All right, what is the probability that all 8 bets lose? Probability of winning is a quarter. Probability of a loss is 3/4. Probability of 8 straight losses. Or if X is a win, probability that X is 0. So, probability that X is 0 is 3/4 to the 8th. Yeah, the probability that X is, I don't know, what did they write this? This would be, yeah, the probability of losing 8 straight times. 1 second. Oh, come on. 0.75 raised to the 8th. Yeah, I don't know why I wrote that. That's probability of, probability that you lose 8 straight times is the probability of losing raised to the 8th. And if you do 0.75 raised to the 8th power, you get this. All right. 10% chance of losing 8 straight times. What I did was the probability of winning 8 straight times. I think I typed that in my calculator accidentally. All right, so 1228, universal blood donors. People with O negative blood are universal donors. That is, any patient can receive your blood. It's one of the O's also makes you tastier to mosquitoes, because my wife has that blood. She gets bit constantly. So, blessing and a curse there. Only 7.2% of all Americans have O negative blood. If 10 people appear at random to give blood, what is the probability at least one of them can give blood? So X is a person with O negative blood. W/ that means with O negative blood. We want the probability that X is greater than or equal to 1. So the probability of X is 0.072. Probability that X is greater than 1 is always 1 minus the probability at 0. That's the probability of not having someone with that type of blood. And so you got above a 50% chance. And with that in mind, I actually want to, well, we're not done yet, but that is the famous birthday question. How many people, so there's 21 of you in class, how many, and ask around, does anyone have the same birthday of you 21? All right, let's test. I want you to know. Everybody say, hey, I was born on this day. Do you all have, I'll even put me in there. Now we have 22, was born August 3rd. Does anybody, now if you had twins, obviously that would be, we'd be done. Does anybody have this, any two of you have the same birthday? So my question is, how many people would you need in a room so that the probability of 2 people having the same birthday is above 0.5? How many people would need to be in the room? All right, obviously less than 183. You might be surprised at how few people are needed. That is one of the famous questions, the birthday problem. And I will give you the basic work either tomorrow or Friday. It's a really good question. You can Google it, but I'm going to help you out with it. So it's surprising It's a surprisingly low number. Now, it's not a guarantee that you all have the same birthday, but it's that the chance of having the same birthday by two different people is above 50%. It's a surprisingly small number. All right. Yeah, that's what I'm going to say. So let's talk about, okay, we're just talking about more gambling here. It's probably not the best one to have recorded. Now, so slot machines are now video games with outcomes determined by random number generations. In the old days, though, slot machines were like this. You pulled a lever to spin 3 wheels. Each wheel has 20 symbols, all equally likely to show when the wheel stops spinning. If 3 are independent, they are independent of each other. Suppose that the middle wheel has 9 cherries, and then the left and the right have 1. You win the jackpot. Those quarters are flying at you if you get 3 straight cherries. So what's the probability of all cherries? The first one, 1 out of 20. Second one, 9 out of 20. The third one, 1 out of 20. I used to make these rectangular or squares a lot in college for different probability questions. Or something like this, especially when multiplication was involved. 1 out of 20 chance, 9 out of 20 chance, 1 out of 20 chance. All right. And that's just 9 out of 8,000, which is a very, very small chance. 0.1% chance winning jackpot. All right, now let's say you get a special prize if you just have two different cherries. Now the probabilities aren't all the same, so it's not like I can figure out 1 and multiply by 3 because that's 1 out of 20, 1 out of 20. But this is 9 out of 20. So here's what you could have. You could have a cherry, other one. You almost won it. So the probability of cherry there is 1 out of 20. Probability of cherry there is 9 out of 20. And the probability of something other than a cherry is 19 out of 20. We have a famous question coming up here. I believe in chapter 12 too. It's just not in this packet. I'll have to give it to you when I get back. All right. You could have a cherry, other cherry, probability of something other than a cherry, probability of a cherry. And then you could have other, 19 out of 20, cherry. So actually you have 2 of those. Okay, and you add them up. Not a great chance, 4.4% of that chance of that happening. All right, and so why is that different than C? B wanted each individual probability. So you'd say this equals this, this equals this, this equals this, but we just did a B and C together. Okay. And lastly today, so chance of any portfolio going up in a given year is 0.65. All right. So what's the probability that the portfolio goes up in 3 straight years? Probability that portfolio, goodness, goes up is 0.65. So it goes up 3 straight years is that. And B says, what's the probability that it goes in either direction for 3 straight years? So probability goes up for 3 straight years plus the probability it goes down for 3 straight years. You get that, and you add them up together. And that is it. That's a nice notes video. Again, birthday question. We're gonna talk about that. Give me your guesses. How many people would you need? I'll give you a hint. It's less than 100. To have in a room so that the probability of 2 people having the same birthday is greater than 0.5. All right, that is my question to you. Show a bunch of good work on your homework set. This is Yak Math Videos signing out.